Somewhere in a quiet workshop in Molsheim, France, a single engine takes over 90 hours to build. Not by a robot, by hand. That engine will end up in a car that costs more than most people's houses. And by the time this video ends, you'll understand exactly why. This is the Bugatti Chiron. $3 million, 1,600 horsepower, and every single part of it was built to answer one question. What happens when money stops being the limit and physics becomes the only enemy left? Let's open the hood. At the center of the Chiron sits something almost nobody else on Earth builds anymore. Not a V8, not a V12, a W16. Picture two V8 engines fused together at an angle, sharing a single crankshaft. 16 cylinders, 8 liters of displacement. It looks less like a car engine and more like something pulled from a fighter jet. Most manufacturers stopped chasing engines this complex decades ago. Too expensive, too difficult to cool, too hard to keep reliable. Bugatti kept going anyway, because reliability wasn't the goal. Dominance was. But here's what makes it truly insane. It's not just the size, it's what's forced into it. A normal high-performance car might run 1 turbocharger, maybe 2 if it's serious. The Chiron runs 4. Each turbocharger force feeds compressed air into the engine, and Bugatti stages them in pairs. 2 spool up almost instantly at low speed. So the car never hesitates off the line. Then, as speed builds, the second pair kicks in, adding a second wave of power exactly when the first one starts to fade. The result is a power curve that never dips, never lags, never stutters. 1,600 horsepower, 1,180 pound-feet of torque. Enough to push this car past 300 miles per hour, a speed most commercial airplanes take off at. And all of that force generates heat that could destroy the engine in minutes. So to keep it alive, the Chiron needs 10 separate radiators, 10, just to survive its own output. This is an engine that doesn't just perform. It fights physics and wins every single time the throttle is pressed. But an engine this powerful needs a body strong enough to survive it. That's where carbon fiber comes in. The entire monocoque, the structural skeleton the whole car is built around, is a single piece of carbon fiber. Not welded together, not bolted from separate panels. One continuous shell, stronger than steel, at a fraction of the weight. Carbon fiber isn't poured or stamped the way metal is. It's woven, layer by hand, sheet after sheet laid at precise angles for strength. Then baked inside an autoclave under extreme heat and pressure, until it hardens into something that can withstand forces that would crush a normal car frame instantly. Every curve, every vent, every intake you see on a Chiron isn't there for looks. It's engineered to move air exactly where the car needs it, cooling the engine, feeding the turbos, creating downforce that keeps the car planted to the road instead of lifting off it at extreme speed. At 300 miles per hour, aerodynamics isn't a design choice anymore. It's survival. Here's something most people don't expect. Bugatti doesn't mass-produce these cars. They can't. Each Chiron takes roughly 6 months to build. Not 6 hours, 6 months. And most of that time isn't robots moving down an assembly line. It's technicians, engineers, and specialized craftsmen assembling this car largely by hand. The engine alone takes over 90 hours to assemble, piece by piece, by a small team trained specifically for this one power unit. The leather stitching inside the cabin, the fitting of carbon fiber body panels, the alignment of components with tolerances measured in fractions of a millimeter. All of it done by human hands, not machines. Bugatti builds fewer than 500 Chirons in total. Ever. Not per year. Total, across the entire production run of the model. That's not a limitation forced by low demand. It's a deliberate promise of exclusivity. And it's part of exactly what you're paying for. Before a single customer ever sits behind the wheel, every design element is pushed past its intended limits. Bugatti tests these cars at extreme speeds on closed tracks, monitoring every system under conditions almost no other production car will ever face. The tires are custom built specifically for this car, rated for speeds beyond 300 miles per hour, because an ordinary tire would simply disintegrate at that speed. The brakes are carbon ceramic discs roughly the size of dinner plates, engineered to bring this 2-ton machine to a full stop from top speed, over and over, without failing. Every bolt, every seal, every sensor earns its place on this car the same way, by surviving conditions specifically designed to break it first. So here's the question you've been waiting for. Why does this car actually cost $3 million? It's not just marketing. It's not just a badge on the hood. It's math. Bugatti builds fewer than 500 of these cars, total ever, which means the cost of an engineering and development program worth well over $100 million gets split across an incredibly small number of units. Every research breakthrough, every specialized engineering team, every failed prototype along the way, all of it gets baked into the price of each individual car sold. Then add labor. Hundreds of hours of hand craftsmanship per vehicle, performed by specialists whose skills can't be replicated by automation and can't be rushed. Then add materials. Aerospace-grade carbon fiber, custom-forged engine components, parts sourced from suppliers who build almost nothing else at this level of precision, because almost nothing else demands it. And finally, add exclusivity itself. When a company deliberately limits how many of something will ever exist, scarcity stops being a side effect. It becomes part of the price tag. You're not just buying horsepower when you buy a Chiron. You're buying hand-built engineering, extreme testing, obsessive precision, and a production run smaller than most neighborhoods. The Bugatti Chiron isn't just a car. It's a statement, proof of what happens when engineers are given no budget ceiling, no compromise, and one instruction: build the absolute limit of what's possible on 4 wheels. 16 cylinders, 4 turbochargers, a carbon fiber sole stronger than steel, hundreds of hours of human hands shaping every inch of it. That's not just what's inside a $3 million car. That's why it costs one.